Hi everybody, welcome to another instructional video. This time I'll be showing you how to code your software app for the bungee jump ride. As you can see on my screen, there is quite a bit of data here. This is our system analysis, our breakdown of the system. And so we're going to use this to help us code our program. Now, as you're watching this video, please make sure to pause and rewind and then go ahead and update your own program and then come back to the video, hit play again and keep watching. And so throughout that process, by the end of the video, you should have a finished software app. Okay, so the first section, I have split up the program app into two sections. One of them is the operator inputs. Now remember, you're coding a program. Oh, sorry, too big. You are coding a program for a bungee jump operator to operate. I'm actually just going to go back to how I had it before so you can see everything there. So a person is in charge of the ride itself, and if a person comes up and wants to ride the bungee jump, the person has to give them their mass and their height. And so the operator will enter the mass and the height right here. That's where they'll enter their mass in cell D3, and then they'll enter their height in cell D4. And then cell D7, after the operator presses enter, it will give the operator the length of rope to add to their bungee cord. Okay, so that is the operator inputs. So the person that operates the ride, this is all they need to worry about, is just this. This section down here is called the computer calculations section. So this is the part where the computer is taking information, making some calculations so that it can give you the length of rope needed. And so over here on the side, I've included a key, a color-coded key to help you figure out what these different colors mean. So the really bright green color is the jumper's data. It's their mass and their height. The kind of faded green color are known as the jump specifications. So they're things about the bungee jump ride that you're not going to change. Like you're not going to change the height they're jumping from. You're not going to change their safety margin, which we want to make a nice 0.5 meters. The bungee spring constant is not going to change. Okay, so and then the length of the bungee cord unstretched will not change either. So those are specifications about the jump that we're going to keep the same for every jumper that wants to ride. All right, so the ones that are coded in kind of are colored in like a faded red color are calculations that computer is going to make so that we can finally make the final calculation for the length of rope. So for example, we don't care if the operator, we don't want the operator to see, okay, well, let's calculate the stretch of the bungee. We don't need the operator to do that. These are calculations hidden behind the scene because all the operator cares about is mass, height, and length of rope. Okay, and so we need the starting gravitational energy and the ending gravitational energy to get our elastic because we know from the law of conservation of energy, we know that our elastic energy is the starting gravitational minus the ending gravitational. And we need that elastic energy so that we can calculate the distance stretched using our elastic potential energy equation here. Okay. So let's get started. Let's get started coding. So again, these are all inputs. These are things that you're going to enter physically into the program. And the red ones are the ones that the computer is going to be making calculations for. So the red ones we actually need to code. So let's start with the starting gravitational potential energy. The starting gravitational potential energy is mass times gravity times height. And it's the starting, so it's the starting height above, which is the height of the jump. So we're going to set this cell equal to the jumper's mass, whatever they enter in for the mass. So we'll set it equal to that cell times gravity, which we've been calling this trimester 10. Gravity is 10 times the height they're starting from. That's the starting height of the jump because it's starting gravitational. So it's this height of the jump, and we'll press enter. And you'll see that 0.0 shows up because we don't have anything in the height of the jump yet or the mass of the jumper. So it's thinking that there's nothing there, so they place a 0 in there. That's why we're getting a 0 here. All right, so there's our first calculation. Our ending gravitational potential energy will be when the jumper's here, their ending height. So we'll set this equal to their mass still, because it's mass times gravity times height. Mass times gravity of 10 times this time their ending height, as you can see, is their safety margin. So we're going to put that number in and press enter. And as you can see, we still get a 0.0 here. And so we needed these gravitational energies so we can find our elastic. Now our elastic is just our starting gravity minus our ending gravitational. So I'll just set this equal to whatever pops up in this starting one minus whatever pops up in this one. And as you can see, we'll still get 0 because 0 minus 0 gives us 0. Okay. So now we have our elastic potential energy. We can now find how much the bungee cord will stretch because we already have our spring constant our spring constant as well. Now this was the really, really tricky part because elastic potential energy, the equation for that is 1/2 the spring constant times the distance squared, right? But we want to solve for distance squared, so we have to do some algebra first. So in other words, we need to get this d by itself. So the first thing I'm going to do is I'm going to get rid of this 1/2. And what I'm going to do is I'm going to bring it over to the other side. Now that is the same thing as saying, if I want to move it over here, I have to do what it's doing the opposite of. So instead of 1/2, I'm going to multiply by 2. So in the end, that looks like 2 times elastic potential energy is equal to the spring constant times the distance squared. And now I need to move the spring constant over, and right now it's being multiplied by d squared, so I have to divide on both sides. And so those will go away. What I'm left with is 2 times the elastic potential energy divided by the spring constant. Now I have this squared up top. I need to unsquare it. And to unsquare something, you have to square root. And whatever you square root on one side, you got to square root the whole thing on the other. So in the end, the distance stretch is going to be this big square root of 2 times the elastic potential energy divided by K. And so this is what we need to code into our stretch of the bungee. And so now I'm going to show you how to do that. To code a square root, you're going to set this equal to, and then you're going to type this out, SQRT. SQRT is short for square root. And then you need to have an open parentheses after that. And inside that square root, we're going to put the rest of that stuff in there, which was the 2 times whatever your elastic potential energy is. So this cell divided by your spring constant. And then once you enter 0, you're going to it's going to show you an error message at first because you're dividing by your spring constant, but we don't have anything for spring constant yet. And you can't divide by 0. So it's going to give you this weird division by 0 right now. Don't worry about that. That will change once we enter data. Okay. And now that you have the distance stretched, and we know that to find the length of the rope, we just take our height and minus all of our other lengths going down. So this length right here, we're going to set this equal to our starting height minus our unstretched bungee cord, which is this one here, minus our distance stretched, which we just calculated here, minus the height of the jumper, which is this cell here, minus our ending height of the safety margin, which is this one here. And when you press enter, you're also going to get a weird division by 0 because we don't have anything here yet. But watch this. Now let's use some of your data that you've got. Okay, so let's say the unstretched length of bungee cord is 0.675 and your spring constant is 7 newtons per meter. Uh-oh, now things are changing. Let's say the height of the jump is 5.5 meters and we know that our safety margin is 0.5 meters above the ground. All right, and so now if we have a mass of a jumper, let's say their mass is 0.023 kilograms, and their height is 0.23 centimeters, which is very similar to the Barbie doll, and we press enter, we can see now that it's giving us a length of rope to add to the bungee cord. So this seems like it works, but now that you have this finished, I have also provided you a check-in to see if it actually works. I'm going to give you some numbers and you're going to calculate and see if you get the correct output at the end. All right, so that concludes this video. If you have any questions, please email me or whoever your teacher is. Either of us, any of us, will be happy to help you. Good luck coding, and I will see you next time.